So R4 is factoring polynomials, and this is going to be all different kinds of factoring. So we've got factor by grouping. We have a perfect square trinomial. There's also a possibility of it being a difference of squares, which that one's not actually written in the notes, but that's another one we could have. Oh wait, I lied. It's right there. We also could have a difference of cubes or sum of cubes, which follows the SOAP formula, which is just an acronym to help you remember what to do at each step. We have the typical arch method that you've been doing for several years, hopefully at this point, and then factoring by substitution as well. So we'll just jump right in. The first ones say to factor out the greatest common factor from each polynomial. So they give us something like number 18, negative 3 z to the 5th w squared minus 18 z cubed w to the 4th. So anytime I'm factoring out the greatest common factor, I want to find the absolute biggest thing that I can take out between however many terms there are, so in this case 2, that is the same that I can pull out so that there's nothing else left that I could possibly take out. So, any ideas what I can take out of this one? And I'm going to make that a negative 3 since both are negative, so that way it'll make everything else like positive later. Negative 3, what else? Yep, I can take out a z cubed. Anything else? Yep, w squared. And even though they have their variables backwards, I like to write them in order, so I rewrote them, but I like them in alphabetical order, but it's up to you. I mean, it won't be wrong if you don't do it that way. It's just my preference. So then everything that's left over, when I factor this out, what am I left with in this piece here? Z squared. Everything else is gone. What about from this second piece here? Well, remember I took out the negative, so this one's going to be positive. So positive 6 what? Yep. And that would be where we leave that. Let's see. 20. 28 r to the 4th s squared plus 7 r cubed s minus 35 r to the 4th s cubed. So now I need to find the greatest common factor between all three pieces. So as far as a number, is there any number that I can take out of everything? 7. How about r's? Can I take out any r's? R cubed. And what about s? Just a single s, because this one doesn't have a power on it, so just an s. So then when I do that, what am I left with this piece when all of this has been factored out? Yeah, 4rs. What about this second piece? 1. So if I take something out, I've got to make sure there's still like a 1 there for it to be multiplied by, because when we if we were to distribute everything back through, it should look just like it did when we started. So plus 1, and then what about this minus 35 r to the 4th s cubed, if I take it out of there? All right, so this next one, mainly doing this one because I want to show you something about it. It is number 26, 5 times, in parentheses, a plus 3, and that whole thing is cubed, minus 2 times, in parentheses, a plus 3, plus, in parentheses, a plus 3, squared. So I'm doing the same thing where I'm factoring something out. What do you see in all three pieces that I could possibly take out? Yep, the a plus 3. And so what that looks like is we'll do, in parentheses out here, a plus 3. And then a lot of times I'll do like a bracket since I'm still going to have more stuff in parentheses in there. So then I'll have 5 times a plus 3 squared minus 2 plus, in parentheses, a plus 3. And that way, it's just clear what everything is. So, anyways, any questions on greatest common factor? Are we okay on that? Cool. So then the next stuff is to factor by grouping, which is usually the step we do after arch method. But you can also just have a problem that's already set up for you in such a way that you can factor by grouping, and so that's what this is. 34, 20z squared minus 8x plus 5pz squared minus 2px. So anytime we factor by grouping, we're grouping like the first two terms and the last two terms, and I guess I should actually do this. This last two has that sign with it. So out of the first two set of terms, what is the greatest common factor that I can take out of those two? 4. So I'm going to have 4 times 5z squared minus 2x. And then out of these last two pieces, what can I take out? Like, what's the greatest thing I can take out? A p. Now, I'm going to also tell you, technically you should put the sign here. I never really write the sign just because, I don't know, it just don't do it. But just remember that when you go to combine things, the sign is important. So when I do that, I'm left with 5z squared minus 2x. And the key thing is, when you're done doing factor by grouping, the stuff in the parentheses has to be the same. If they're different, can't do it. So if they're different most of the time, it means that you factored out something that was either too big or not enough, is usually the problem. Because sometimes you can't always take out the greatest common factor, but it has to be something less to make it look like the other side. So, anyways, so now we rewrite this. Whatever the duplicated term is, I only write it once. I'm sure you all already know that, but I have 4 plus p in one, and then write that down one time, so 5z squared minus 2x. Does stuff look familiar? Or maybe not done in this exact way if you've done it like after the arch method before, but sorta, maybe, kinda, not really. Okay, well, I'm not really going to do any more of just the factor by grouping ones, because as we go through and do arch method, that will be included with that, so we'll do a little bit more of it, but not just in the section of just doing that. So the next one, say to factor each trinomial, so it might be with the arch method, it might be with a special type, who knows, but also every single problem in the book is not gonna all be factorable, right? Sometimes we get one that's not. And so once you've tried kind of like all your options, if it's still not factorable, just write not factorable, not possible, something like that. So number 40, we have 9x squared plus 4x minus 2. Also, other thing I'm going to say is I use the arch method. I'm sure some of y'all remember Ethan, but he had a different method for doing this kind of factoring that still worked and got to the same answer. It was just how he was taught. And so if there's like a different method that you know, like if you had my mom here, I know that you were probably taught arch method or maybe a box method. Tyson, I'm not sure with where, like, what your math teachers before would have done. So if you're looking at this when I do like the arch method and you're like, I've never seen that before, and you have a different way, that's totally fine too. So I don't really care how you get to the final answer as long as you show me that how you got there. I don't know. Ethan attempted to teach me his method because it was really cool, but I just could not figure it out. I was like, I don't understand. It was like a slide box method or something. I don't know. Anyways, so we are going to do the arch method. Oh, wrong color. 1 second. There we go. So arch method, we multiply the first number and the last number and get a negative 18. And I need factors of negative 18 that when added together give me a positive 4. So what are some factors of 18? Do what? 3 and 6. I don't know why I thought you said 8 and 6. That's why I was like, huh? 3 and 6, when I add those together, I don't get 4, so that's not going to work. What else? 9 and 2. That when you add them together, and technically because it's a negative, one of these is going to have to be negative. But 9 minus 2 is 7, so that one's not going to work either. Any other options? So the only other thing those are the only two options outside of 1 and 18, which that also doesn't work, obviously. But that is the most common one that people forget, is the one that's like 1 and the number itself. And a lot of times that one ends up working. In this case, it doesn't, obviously. None of these options work. So this is one that is not possible. So one of them, right off the bat, not possible. So let's see if we can find one that is. Let's try 42 and see. This one is 36x cubed plus 18x squared minus 4x. Now, what do you notice about this problem specifically compared to like the other ones? There's a cubed. What else? Yep, every term has an x. So I don't have a special factoring method that works for that. However, I do know how to factor out the greatest common factor. And so I am going to do that. So, and it doesn't have to just be like the variable. So is there a number that I can also factor out? By chance. 2. So I'm going to take out a 2 and an x. Now, the tricky part here is people tend to forget that 2x has to stay with the problem. That's just something that's been factored out. It's going to be part of your final answer. And so then I will put in parentheses. That gives me 18x squared plus 9x minus 2. And so now what I'm going to do is the stuff in parentheses, I'm going to attempt to use the arch method to find factors for that. But this 2x is going all the way down the problem with me, all the way till the end. So I need factors of 18 times negative 2, so factors of negative 36 that when added together give me an 18. Obviously, since that number is negative, one of these numbers down here has to be negative. So any guesses on factors that will work? So two numbers multiplied together. Combine and give me, oh wait, I'm looking at the wrong thing. Disregard, 1 second. Add up and give me 9. I'm looking at this part down here. I was like, something's not right because there's not factors that are going to work for that. So, yeah, there we go. So factors of, now that I've thoroughly confused you, negative 36 that when you add them together give you 9. Negative 12 and 3. So I'm actually going to flip that sign since this number is positive. I want the bigger number to be positive and the smaller number to be negative. So it'll be a positive 12 and a negative 3. So this is getting really blurry. And I try to line up numbers that I can see are going to easily like factor. So I'm going to do the negative 3 first and then the 12 second just for things. Well, never mind. Disregard what I just said. I'm going to do the 12 first. So I'm still bringing down that 2x. So I just drew my arrow so I know that it's coming down and I don't forget it. So I've got 18x squared plus 12x minus 3x minus 2. Factor by grouping. So what can I take out of this set? 6 and what else? Yep, 6x. And that gives me 3x plus 2. What about over here? So I know that I ultimately need it to look like this. So if I take out the negative, so I'm taking out a negative 1, then I'm left with 3x plus 2. Now those things match, and so then my final answer is going to be 2x that I had taken out from the beginning times 6x minus 1 times 3x plus 2. And that would be it. Let's see. $46. 12s squared plus 11st minus 5t squared. So what is different about this one compared to the other problems? Aside from the fact that the variable is an x. Yeah, there's 2 in the middle. We have 2 different variables, right? And the first one and the last one have a square on them. So I need to figure out factors still of the numbers, but I also have to include the letters. And so this is one that you also have to pay really close attention to and just how it's going. But I need factors of 12 and negative 5, so negative 60, that add up to give me a positive 11. Any idea what factors might work? or any that I can try. So 5 and 12. I'm going to combine those. That gives me 17. Or, well, since I have to subtract one of them, that would give me 7. So that one's not going to work. What else? 3 and 20. Is that what you said? So that one, 20 minus 3 is 17. So that one doesn't work.
15, -4.
15 and -4. And that gives me my 11. So that's the one I'm looking for. So when I do this, I have, let's see, 12s squared minus 4, and I've got to make sure I get the s and the t here, so st, plus 15st, and then minus 5t squared. So that's why I said now you just have to make sure you pay attention to the variables to make sure that everything is working correctly. And so when I do my factor by grouping, what am I taking out over here? Yes, 4s, which leaves me with a 3s minus t. What about this one? 5t. And that gives 3s minus t. So then combine this stuff together. 4s plus 5t. Make my s look a little more like an s. Times 3s minus t. Like that. So that one, obviously both pieces of those factors have a variable in them, which we don't see too often, but can happen. This one is factor each polynomial. So the other ones were all trinomials. Obviously they had 3 terms in them to start with. These ones could be special types and have different amounts, anywhere from 2 to 4 terms. So 60. I've got 16q squared minus 25. Does anybody recognize what this is?
Perfect squares.
Difference of squares, because there's 2 terms. So, anybody remember what, in general, a difference of squares factors into?
X squared x plus y times x minus y.
Yep, it would be like an x plus y times an x minus y. Now, obviously, that would be if we had the scenario of x squared minus y squared, then that gives me an x plus y and an x minus y. So these terms here are squares of something, okay? So what are they squares of? Like, what is 16 a square of? 4. And what is 25 a square of? 5. So sometimes I like to rewrite this when they're written this way as like 4q and then the whole thing squared minus 5 squared, just so I can see it, so it kind of looks like this. So then based on that, what is this going to factor into? Basically, imagine this is x and this is y.
4q plus 5 times 4q minus 5.
Yep. Nice and easy. All right, this next one's a little bit of a weird one, but works the same way. in parentheses, I have p minus 2q, and that whole thing squared, and then minus 100. So this one is of a different form to start with in terms of how it looks, but it's the same thing. It's still a difference of squares because I have a term here being squared. This is one singular term that's being squared. And then 100 is the square of what? 10. So I'm going to think about this as 10 squared. And so when I write this one out in factored form, I'm going to get in parentheses, in parentheses, I have another little parentheses for the p minus 2q. Close that little parentheses, plus 10. Close the big parentheses. Another big parentheses, little parentheses, p minus 2q. And then close that one, minus 10. And so, works the same way, just looks a little different. Have y'all seen ones like that before? One has. Kind of. Things can look scary, so if you see something like that where you're like, well, I know this whole piece is being squared, but like you feel like you're going to get it all confused, just like cross that piece out and make it an x, and then rewrite everything in terms of x, and then just substitute it back in when you're done. That's another way you can do it if it's confusing that way. See, we haven't done a cubes one yet. So 74, 27, actually, 27 minus r cubed. So this is going to be a difference of cubes because I see that both terms are cube terms. What is 27 the cube of? 3. So this is going to be 3 cubed minus r cubed. And this is where I'm using that SOAP formula that you had in your notes. So for a difference of cubes, what we do is we have whatever the first term is minus the second term. So you have the same exact sign in the first one. And then you close that parentheses. The next parentheses is the first term squared. So we square that. Then this sign is opposite. So that's from the O in SOAP. So opposite sign. And then we do the first term times the second term. So x times y in this case. And then the last one is always positive. And so then that's going to be a plus sign with y squared. So when I do this now, you copy it down exactly just without the cubes on it. So this is going to be 3 minus r. So that's the same sign. Then in here, we square the first term, so 3 squared, which I'll rewrite in my final answer, but just for us to see it. So same sign. The next one is opposite sign, so it's going to be a plus. The first term times the second term, so 3r. And so that was my opposite sign. And then lastly is always positive. And that's the last term squared, so r squared. So the always positive part of that formula there. And then I just need to rewrite this so that I actually square the 3. And if you wanted to do this in like one step and not have to rewrite it, you could have gone ahead and written that as a 9. You don't have to like wait, but just for the visual. So I have 3 minus r times 9 plus 3r plus r squared. And that would be my final there. Let's see, I want to do one more cube one. 76 8m cubed minus 27n cubed. So still cubes. So what is 8 the cube of? 2. So when I rewrite this, I'm going to call this 2m and the whole thing cubed so that I have that piece ready. Minus, we already said 27 is 3 cubed, so 3n and that whole thing cubed. So now I have both pieces rewritten as, in parentheses, something cubed. So when I rewrite this in factored form, what do I write in the first parentheses? You can look at the previous one for reference.
2m minus 3.
2m minus 3n. And then the next parentheses.
2m squared plus 3n squared. Nope. Plus 2n 3n. Plus 3n squared.
Yep. And so if you wanted to go straight to the final answer instead of doing it in like pieces, that's fine, but setting it up this way is great too so you can see everything. So then ultimately this gives me 2m minus 3n. So that was our same sign. Over here we would have 4m squared. Opposite sign, so it was positive. So that gives me 6mn, and then plus, because it's always positive, so it runs away, 9n squared, and that would be your final answer. And you don't have to write the little SOAP acronym above it every time either. I just do that for a visual. Any questions on that? The only thing out of this section that I didn't specifically really go over is if it tells you to factor by any method, that means that you have to choose the method to use. So typically on a quiz or a test, I'm not going to say like factor the polynomial or factor the trinomial. I'm going to tell you to just factor using any method, and you need to be able to distinguish what method to use. But I do try also on quizzes and tests to give you the instructions like it would be in the book, but that's why I'm telling you, like, I may just say factor using any method so that you have to pick it, but obviously in the book it says to factor, so just be aware of that. So problems for today: 17, 25, oh wait, hold on, let me go back and make sure. Yeah, 17, 25, 31, 35, 49, 59, 75, and then 2 that are out of the section for factor by any method. 97 and 103.